And I'm going to invite Professor Tim Smyth now to introduce himself and give the next talk. So thank you, Tim.
Thank you, Matt. So my name's Tim Smyth. I've been working at PML for about 27 years now, and I'm going to report on the oceanography around our coastlines. And I make no apology for this, but a lot of this is going to be meteorology as well. So what is the Western Channel Observatory? So the Western Channel Observatory, as Icarus said in his introduction, is a set of time series stations that we operate off the coast of Plymouth. So does this work? Just about. So we're obviously up here in Plymouth. Our primary stations of occupation are L4, which is about 4 nautical miles due south of Rainhead in 50 metres deep water. Seasonally stratifies between about now and September time. And then the station E1, which has got a very long provenance, goes back to 1903 in terms of being sampled. It's one of the IC stations, and this is in 80 metres deeper water, about 20 nautical miles off Plymouth. If you imagine where the Eddystone is, it's about double the distance away that the Eddystone is. And what are the sort of things that we observe at the Western Channel Observatory? So we've got an atmospheric time series station that we set up a decade ago now at Penlee Point in the Trinity House hut. So if you're going on your walks around the coastline, we've got a load of instruments in there. So you might be able to hear pumps and fans and all sorts of stuff going on in there. We also, as I've already mentioned, sample throughout the water column. So pelagic is through the water column at L4 and E1, L4 once a week, so generally on a Monday if the weather's not very good, on a Tuesday if the weather's not any good, on a Wednesday, and you get the idea. We've been sampling a lot on a Thursday. E1 we try and sample once a fortnight, but usually in the winter once a month. And then we've also got a benthic set of time series stations, mainly concentrating on just around about L4. So we've got benthic time series that's gone on for probably about 20 years now, continuously. So now the next 5 slides are going to be what the regional picture has been in terms of the meteorology over the last year. So just cast your minds back when I talk about winter 22-23. So that's not just the winter we've just had, it's the winter before. And the next 5 slides are going to be the wonderful maps that the UK Met Office provide. So if you follow this link here, don't imagine you can write it down, but these are the 3 maps. So what we've got here are mean temperature and this will be the anomaly from the 1991 to 2020 anomaly. So that's a 30-year time series that all the anomalies are taken from. Meteorologists like to work in slabs of 30-year climatologies. In the middle will always be the rainfall, and on the right will be the sunshine percentage of the average. So red means it's warmer, brown means it's drier, blue means it's wetter, and then orange means it's sunnier, and grey means it's cloudier. So there we go, there's a little bit of orientation for the next few slides. So we can see that winter 22-23, pretty average in the time series, but that actually glosses over an awful lot of detail, which I'll show in a moment. It was quite dry actually. February was remarkably dry, 2023. It hasn't been since. You don't need me to tell you. And it was pretty average in terms of the sunshine, just a little bit above average. But all of these statistics, all these kind of regional maps here, kind of gloss over a lot of detail. So let's have a look at this. So now we're looking at the temperature. So this is the mean temperature for winter 23. And so an average would be along the black line here. And where we've got positive anomalies, that's where we go into the red. Where we've got negative anomalies, that's where we've gone into the blue. And actually, at the start of winter 22-23, there was very, very cold. If you remember rightly, just before Christmas, it was remarkably cold. In fact, right down at almost the absolute minimum that we'd ever seen in that 30-year period, just before Christmas. But then kind of normality returned with kind of a pretty mild end to the year, and then into January, we then had another cold snap, which didn't last very long, and then the rest of the winter was actually pretty mild. In fact, almost up to the absolute maximum. So it was a flip-flop winter, and if you look at the map that I just showed here, you'd think, well, it's pretty average, but actually those extremes you don't really pick up with these kind of maps. Right, let's do spring. So spring, warmer than average, a lot wetter than average, so we're getting up to 130 to maybe 150% more rain than we'd expect on the climatological average, and actually most of that was collapsed into sort of March, April time, I think, and then it was pretty average in terms of the sunshine hours. Let's have a look. So again, we've got this rapid fluctuation now in terms of temperature. So the beginning of spring it's a bit like now, isn't it? It's right at the kind of very cold start to the spring, but then we kind of got this kind of flip-flop between cold and warm, which then obviously gave us an average, a pretty average spring in terms of the temperature. Right, so summer 2023, you will all remember all the heat waves, but we don't see the heat waves so much on this because July and August were actually particularly poor, but June was quite remarkable. So in terms of the anomaly value, we were getting around about half a degree above average. Again, it was relatively wet, but not exceedingly wet in the summer. I think our bacon was saved really by June being particularly warm and dry. And it was relatively dull, but kind of, again, that kind of glosses over the astonishing heat wave that we had during June 2023. So this is the heat wave period here. Very long duration. Generally, you expect heat waves to last 1 or 2 days. This one did not. So the heat wave really lasted from about the first week in June all the way to pretty much the end of June. You can almost set your watch by when the school goes on holiday. So again, this was basically the rather damp and dull summer and cold summer that we had. And then this is when I went on holiday, which we had some really rather nice warmth in September, just for a week, really. And then it went back to being cold again. And then into the autumn 2023, so this takes us through to November 2023. Again, now we're getting up to some pretty good, positive anomalies here. So a degree to a degree and a half warmer than average, wetter than average. So we're looking at 110 to 130% average. We're no longer in a hosepipe ban at this point. And then again, duller than average. And these are what the temperature, again, this is early September. So this is when I had my holiday. Sorry, I was jumping the gun. This was remarkably warm. So this heat wave period that we had here was quite astonishing. Actually, it broke a lot of records, and you can see overall, the autumn last year was remarkable in terms of its heat. And then winter that we've just had. So we're about half a degree to a degree warmer than average down here. A lot wetter than average. I mean, we're getting up to 150 to 170% of our average rainfall in our region, and then a lot duller. But you don't need me to tell you that. And then there you go. It's astonishingly, this kind of flip-flopping of the weather that we've been seeing over the last year or so. You know, we've had some remarkable warmth, but also interspersed with some relatively notable cold. I remember this was relatively cold in January. Okay, so how am I doing for time, Matt?
You've got plenty of time actually.
Good.
About six minutes or so.
6 minutes, okay, right. Okay, so how does this translate into what we see in terms of the meteorology? So now I'm going to take you through a series of sort of postage stamps. So we go from January 2023, February, March, April, May, June, so the first half of the year in terms of the sea surface temperature anomaly. So I thank Emma Sullivan for providing me with these anomaly plots. So this is the temperature data that we get from the satellites. It's against the anomaly. Again, we try to go for this same 30-year period for the anomalies are against. So you can see that into the first 3 months of the year, we're probably about 0.2 to 0.3 degrees above average, but quite flat. We're not really seeing much in the way of temperature extremes until we really get through into, and this was where we had the BBC obviously knocking on our door about all the extreme or the marine heat waves that we were seeing around the coastline. So this was, we were getting temperature anomalies 2 to 3 degrees above the mean in the region, and that's quite extraordinary actually. Atmospherically it isn't, but when you go into the ocean, because of the thermal inertia of the ocean, those marine heat waves were very notable. Then once we go into July and August, you can see this is when we had the much cooler period, and I'll show the station data in a moment. And you can see that the temperature anomalies, again, we go from a period of it being marine heat wave to, particularly around the coastlines, the temperatures were pegged right back, probably sometimes up to a degree or so below average. And then once we go into the autumn, the temperatures go back to where we would expect them to be, above the average, and then a bit of a sort of average end to the year in terms of the sea surface temperature. What were the winds doing during the year? So again, back to winter 2022-23. These are data that we get from the Rainhead National Coastwatch Institution. So we operate their Met station there. We do a lot of their data analysis. So you can see what a wind rose shows you is the dominant direction of the wind. So here's west, here's east, here's north, here's south, and then this is the percentage of time that the wind is in a particular direction. So it's about 20% of the time the wind was in a westerly direction, and then the colours here show you sort of the intensity of the wind. And I think that the take-home message here is there were no significant wind events during winter 22-23. Remember, that's the winter prior to the one that we've just had. Spring 2023, again, a very mixed wind direction in spring. And generally our springs now are having a much more mixed wind direction, sort of oscillating between westerly and easterly. Interestingly, we seem to have had stronger winds last spring than we had during the winter, which is unusual, and which is an oddity, but I haven't really looked into that in any great detail. But again, quite a mixed bag in terms of the wind direction. Normal service resumed pretty much during the summer, so we're going much more towards southwesterlies in the summer. And again, I think the thing to note again is that the winds were very light. That was one of the contributing factors behind the marine heat wave we had in June. And then autumn 23, again, very similar to summer, so southwesterly dominate again, but not much in the way of extreme wind speeds last year. Okay, so let's look at named storms for 2023. Right, this then starts to become interesting. So storm name, I always say this, storm naming becomes confusing because all Met agencies have their own names. They don't stick to the ones that the UK Met Office and the Irish Met Service provide. So we had this rather unusual thing happen in the summer, that we did not have any named storms in year 2022-23 until August. And the end of the reporting period is actually it goes from September all the way around to August. So we had we had an A and a B in August 2023, and then we started again. So that's why we had an A, B, C all the way through. And then you can see that this year, since sort of September, we've had all the way through to J. I think we may have had more than this actually, but I haven't noted which they are, but we only are interested up to this point here. So the names to remember in the next few plots: Kieran, Debbie, Ellen, Fergus, Gerrit. And these are all the ones that we had sort of all the way from September onwards. So when I talk about Kieran, then I can't remember what they are. Anyway, D, E, F and G. This is kind of the wind speeds that we were getting with some of these storms. So we were getting up to about 70 knot wind gusts at Rainhead. And then so hurricane force is around about, so force 12 is 60 knots and above, sustained. These are the gusts, but we were getting sustained wind speeds up to sort of 60 knots in this particular named storm. But not all named storms are equal, because they all have slightly different storm tracks. But this is kind of to give you a general idea of what those storms hit. And you can see that they're all congregating in that particular part of the year, nothing at all at the early part of the year. We did have some wind events, but nothing on the scale of the end of 2023. This is what was happening at at Loo Bay in terms of their wave height. So this is operated by the Channel Coastal Observatory, and you can see these different wind named storms coming through. So we're getting significant wave height up to about 6 metres in Lou Bay, which is actually quite astonishing. As you go further offshore, if you go out to E1, you start getting wave heights in excess of 10, 12 metres. I'll report on that probably in the actual report. So that was what was happening with the waves. Right, in terms of the local hydrography, so we've actually eventually got through to some oceanography. So this is our time series station at L4. If we go all the way through from January 2023 all the way through to December 2024, this is the depth here on the y-axis. This is what the temperature does, and this is typically what a year gives you in terms of that your water column is well mixed, temperature top to the bottom about sort of 10, 11 degrees. In the winter time, you start getting the stratification around about sort of late April or mid to late April, and then you start getting this surface warm layer that's generally about 2 to 3 degrees warmer than below. And then once you get through into September, October time, that mixes all the way back down through the water column. So that was the picture that we have from this year. You can see the heavy rainfall events that you get. So what happens is that the water runs, obviously falls on the land, washes through the river, and then you start getting the riverine inputs at L4. So we get much fresher waters, something like 0.5 PSU less right at the surface. So these surface lenses that you get of fresher water. We had a late spring bloom last year, or a spring bloom last year was in late April. And you can see it here in the fluorescence signal and also in the oxygen signal. And then we had a succession of summer and autumn blooms in August and October last year. So this is where it starts getting really interesting. So this is the temperature anomalies at L4. So we go from late 80s all the way up to the current day, where you've got temperatures, where you've got blue dots here. That's where you've got a cold anomaly, red warm anomaly. Where you've got a very dark red spot, this is where we're getting what we call a marine heat wave. We actually had to look at better ways of 1 minute. Okay, I think we'll be all right. We needed to look at better ways of how we could visualize our data. So we can see here, these are where we're starting to get at temperatures that we've never really measured before in the time series. So getting temperature anomalies above the 90th centile in terms of surface temperature, and that's reflected all the way through the water column. So this was where we had the extreme heat wave in June of last year. Then it went back to sort of average, and then we got a late heat wave again in the September. So right above, it's above the 90th centile, which is the description of a marine heat wave. And actually some of the temperatures we were recording at L4 were the absolute maximum that we'd ever recorded on a particular date of the year. If you need to know more details, I'm available at the coffee break. Okay, so a little bit about the salinity. I won't go into too much detail there. This is what we saw at E1. The great thing about E1 is that we go back to 1903, so you can see that there's been an inexorable rise in terms of the temperature and also the increased frequency of marine heat waves during the series. And then last year, I suppose the thing to note are, again, the June heat wave here and sort of the heat wave that we picked up in September as well, and the disappointing summer that you can see sort of in the middle there. And that's unpacking that, and that's the salinity. And then finally, talking about the nutrients. So obviously I've talked a bit about the temperature. This is all about the fueling the phytoplankton. So what the nitrate generally does of a given year is that we have sort of a winter time nutrient level somewhere between sort of 5 and a bit and up to 10 in the winter time. This is when our nutrients get recharged, and then as soon as the spring bloom starts, you start to deplete your surface and throughout the depth nitrate, and all the way through the summer and into the early autumn. That's where we've got low levels of nutrients before they recharge back up again in the autumn. And then similar with phosphate, but we're never limited by phosphate at L4 at all. So those data are available there. So thank you. I think I've finished in less than a minute.